Okay, let's get started. Hello, everyone. Hello, everyone. So let's begin our topic. And today, the topic is going to be on method 25, which is Calc 2. And today we're going to talk about like the application unit, which is section 6.4 is the work. So I bet some of you are taking physics 121 or now taking, and is like the concept of work is a force times distance. So it's force so work is force times distance. And now putting the count content, it should be like the work is distance of force they're changing. So they're like we express them like a definite integral. So the work equals like a limit in largest infinity here is going to be sigma notation in I equals to 1 force distance, and as a definite integral from B to A, force is a function and distance is another function. And now let's introduce some of the unit conversion about some question, because like there's like a lot of unit conversion for work problem. Like 1 kilogram is 1,000 grams. One foot is 12 inches. And 1 mile, it is 5,280 yards. And 1,000 meters is 100 centimeters, 1 meter. And with some unit, it's like the work. It's like a metric or imperial. It's like this kilogram is acceleration is 9.8 meters per meter per squared. Imperial feet. 32 feet per square. It is a Newton pound. And it's like meters feet. The work done is be joules or foot per pound. And today I will introduce first type of problem. It is the leaky bucket. So leaky bucket is things like the water is leaking at a constant rate. Which is the linear function is f of x, it is mx plus b. Perhaps this is the leaking function. And the force is f of x. And the force perhaps it is fxi. And the distance from one point to another point, it is delta x. And the work done, it is definite integral b to the a x dx. So the tips is regardless of what kind of problem it is, just label all the conditions and draw a picture. Label and just visualize. Let's try an example. Try example 1. So the water bucket is lifted 20 feet at constant rate. At a constant rate. And a bucket leaking water is a constant rate. Leaky and constant rate also. constant rate of, yep, it, and it doesn't say what is the rate. Initially, the weight, it is 80 pounds. The bucket and water, it is weighed 80 pounds and become 50 pounds later. When it at the top. So how much work it is done? So how much work is done to lift the bucket? Okay, so we have this. So we just try to visualize. This is the first step. Here's the bucket. This is the height. It become like a distance. It is vertical, so either vertical, so column delta y is equal to 20. Y equal to a 0, which is initial. So the rate is going to be leaking 80 to 50, right? Of leaking. Is 80 minus 50 minus 20 feet. Is 1.5 initially going to be negative 1.5. So this is like a slope. And the force, so we need to find the force function. So when the height is 0, the weight it is 80 pounds. So we have is Fy is the function. And it's going to be a negative 3/2 y minus 0 plus 80. Because it's just initial weight. So f of y, it is going to be negative 3/2y minus 8 plus 80. And the distance is 20. So the total work needed is the distance of 20 to a 0. So this is gonna be, so this is a force. This is the work integral, just compute the integral that you're finished with this problem. Compute this problem. This is going to be 1600 minus 400 minus 1600 over 3. So it's going to be 3200 over 3. Be like LB. This is the work need. So this is the work needed to lift the bucket. Let's do another example. Example number 2. A sandbag is lifted at 5 meters. Make sure watch out the unit, because sometimes in feet, sometimes in meters. And the constant rate. And a bag leaking sand, however, like the sandbag is leaking. Sand's leaking out as, and also at a constant rate. Its weight 40 pound is 40 Newton initially. And is 28 feet when get to the top. Oh, 28 Newton, not feet. Oh my, I'm sorry. Get to the top. How much room down with the setback? We'll lift the setback. So let's draw like a visualize. And it's like the same thing is a setback. This one, his one delta y is the height. Here's a 5 meters. Initial height is 0. So the rate of leaking it is. Hence the P 40 minus 28 over 0 or 5, going to be negative 12 or 5. Find the force function. Fy. So pay attention to like the variable. If it's a vertical action, use y. Horizontal action is x. So find the function initial weight. It's going to be negative 12 over 5 y minus 0 then plus 40. So Fy, the force, it is negative 12 over 5 y plus 40. And the distance is 5. So the total work is going to be the definite integral 5 to 0. Then it's going to be 40 minus 12 over 5 y dy. Then what's just the work just to compute this integral? That's just the work for this type of problem. So it's going to be 504 or 150 is like 30. 170 joules of work. So do you want to do another example? Yeah, maybe try it. It's like a leaky bucket. So a small rocket. So what we just call it an object. It ejects from the ground level, injected ground experience as it's more distance travel and the weight is reduced. Travels more distance. So the weight of the rocket, no, as in the object, you can call them rocket, rock, or whatever thing is. When it is x meter off the ground, so it's upward movement, upward velocity. Is given by the function is f of x will be 20 plus 60 L to e to the 2x. And unit is in like newtons. Find a rocket. Now find a work or the object. By the object, it is 10 meters off the ground. They're like a word problem. Wow. No matter what kind of object, draw a graph to visualize. It's just like this is 10 meters. This may be not like a thing, but it's just the how I visualize the thing. So the first option is already provided. So we just need to do computation this time. Actually, it's gonna be dx this time, not dy, because the variable is y. So it's just gonna be two integrals. Make sure to use substitution. So it's gonna be 200. So plus is gonna be 20, and as 0 is gonna be 30 du du. And we do like the u sub is gonna be 170 plus 20, 30 e to the 20. This is the work that needed to lift the object from the ground level to 10 meters high. So here's the tip, like a leaky bucket problem. Here's the tips. So visualize the questions. Number 2, label everything. Into label. And number 3, if it's a constant rate, try to find a linear equation. And then just have integral, set up integral. Number 5, make sure to convert to unit and computation. We're done with the work problems. Okay. So that's all for like the leaky bucket problem. And for next video, I'm gonna introduce like the chain, the pumping problem. And it's like another type of the work problem you encounter in Method 25 and Physics 121. Thank you so much and have a great day.